right, this is going on page 42 when we're done. So we talked a little bit about angles yesterday, about how to name them and read them and things like that. So we've got some relationships between angles that we're going to talk about today. So our first definition is of adjacent angles, A-D-J-A-C-E-N-T, adjacent angles. Okay, they are two coplanar angles. Okay, we're not in 3 dimensions here. We're in 2 dimensions. I can draw them on the paper. They're not jumping out and doing anything like this. Okay, 2 coplanar angles that share a vertex and a common side, but do not overlap. Okay, so they have to share a vertex and a common side, but they don't overlap. So they could look like this. Draw these. So in this picture here, how many angles exist in this picture? 6. So you got 1, 2, 3, the ones that are numbered. 4 is the big one, and then 5 and 6. Does that make sense? Okay. Now, if we look at the little angles, the 3 little angles, are they all stuck together? They're all stuck together, right? I could pick them up and they're all stuck together. They all share a vertex, right? If we're just looking at angles 1, 2, and 3, they all do share a vertex. Do they all share a common side? No. So if you look at angles 1 and 2, do they share a side? Yes. If you look at angles 1 and 3, do they share a side? No. They're only stuck together by the vertex, right? So that's the difference between adjacent and not adjacent. So angle 1 and angle 2 are adjacent angles, and I'm going to abbreviate it ADJ. Okay, that does not mean adjective. That's what you're used to thinking it means. Adjacent, and then the angle symbol with an S for angles, and we can write less. Okay, so adjacent angles is what that says. And then angles 1 and angle 3 are not adjacent angles. Everybody okay with that? So adjacent angles, probably a new terminology for you there. All right, what about linear pair? Have you heard those angles before? Some of this is new, some of it is not, but they are, so 2 angles are a linear pair. Linear pair. Linear pair has to share a vertex. Right? And a side. So if they share a vertex and a side, what do you already know that they are? Adjacent. So linear pair is always adjacent. They're always stuck together. Okay? So they share a vertex and a side, which instead we could just say they are adjacent angles. And they're non-common sides. Right? So if you look at angles 1 and 2 up here, they share a side, right? This side and this side on the outside, those would be their non-common sides. It's the sides that they don't have in common, right? So what does the word linear make you think of? Line, right? So they share a vertex and a side, which means they're adjacent, and their non-common sides form a line. That's what makes them a linear pair. Okay. So over here, these angles, and this right here, these, see, they're adjacent. They share this side. Their non-common sides form a line. So 3 and 4 are a linear pair. 1 and 2 are also a linear pair for the same reason. Okay? This angle and this angle, right? Those are not a linear pair. They share a vertex, but they don't share a side, so they're not even adjacent. So these are linear pairs. Okay? You can abbreviate pairs with PR. So PRS. Over here, these 2 are adjacent, right? But their non-common sides don't form a line. Looks like it's broken, right? And same thing here. It's like it's open too wide, so those do not work. Then these, although if I did stick them together, would their non-common sides make a line? Yes, but the problem is that they're not stuck together. They're not adjacent, right? So they're not a linear pair. So these are not linear pairs. Everybody okay with that? We good? All right, so let's look at this picture right here. Got a lot going on in this picture, so try and identify these angles differently. It says, tell if the angle pairs are adjacent only, adjacent and form a linear pair, or not adjacent. Okay, so we're going to start with angles 1 and 2. So here's angles 1 and 2, right? So are angles 1 and 2 adjacent? Yes. Okay, so they are adjacent. Do they form a linear pair? No, so they are adjacent only. All right, so then we're going to look at 1 and 3. Are they adjacent? Yes. Do they form a linear pair? Yes. Okay. If you have any questions about these, make sure you speak up. Even if everybody's saying yes and you're like, I totally don't get it. You have to not be afraid to ask, okay? Because otherwise I'm going to assume that you get it, because usually you do with this stuff. But all right, 2 and 4. Are they adjacent? What does adjacent mean? They have to do 2 things. Share a vertex and share a side. Do 2 and 4 share a side? Yes. Do they share a vertex? No. Okay, so they are not adjacent. If they're not adjacent, is it possible they could be a linear pair? No, because linear pairs are adjacent, right? So if you decide they're not adjacent, you don't even have to waste your time thinking about linear pair. Now, are they attached to the same line? Yeah, but that's not what linear pair means, okay? If they're not adjacent, they're not a linear pair either, because they don't share a vertex, okay? So not adjacent. Alrighty, so then we're looking at 4 and 6. Are they adjacent? Yes. Linear pair? Yes. Okay. Then 5 and 7, adjacent? They share a vertex. Do they share a side? No. So they're stuck together, but they're not adjacent, which means they can't be a linear pair. Right? So they are not adjacent. All right, what about 5 and 8? Adjacent? Yes. Linear pair? Yes, because non-common sides form a line there. 7 and 8. Yes and yes? Yes and yes. Okay, so it's a linear pair. I want to look at one more, I think. Let me look at, let's look at 6 and 8. 6 and 8 isn't on that list, but I want to look at that one. So 6 and 8. Are they a linear pair? No, because they're not what? Adjacent, okay? And do their non-common sides form a line? No, because this is the side that they're sharing, right? And so these are their non-common sides, so none of that works. Okay, just because they're stuck to the same line does not make it a linear pair. We good? Okay. All right, so now we have some angles that are formed by 2 intersecting lines. All right, these are called, so it looks like this, right? 2 intersecting lines, like an X. Okay? These are called vertical angles. So vertical angles are angles formed by 2 intersecting lines. So in this case, they share which, if you look up here, this is 2 intersecting lines, right? Okay, but these 2 right here are a linear pair. That's not the pair we're talking about right now. That's why the rest of the definition is important. They share a common vertex, but not a common side. So here are 3 examples of intersecting lines, right? So here, angles 1 and 2 that are labeled here, those are vertical angles. These 2 that also get created are a linear pair, but those aren't the ones that are numbered here. Okay, so you got different kinds of angles that are actually made there, but those are my vertical angles. It's like the inside part of the X. Okay, and if I was to close my X, I'm squishing the same 2 angles, right? And then these, if we looked at their names with the 3 letters, because we can't call it E, right? So these are vertical angles. Vertical angles. Over here, we have the intersecting lines that create angles, but the ones that are numbered are the linear pairs. There are vertical angles that exist here, but not the numbers that we're talking about. This is a common misconception of vertical angles, okay? feel like, oh, they share that vertex, these two have to be vertical angles. But are these two angles created by two intersecting lines? No. How many intersecting lines would it take to create that? 3, because you got 1, 2, 3, right? It's kind of like there were vertical angles, but then it got broken, right? And somebody tried to flatten that out, all right? So there's not two intersecting lines here. And then here, that's just nothing like this. So these are not vertical angles over here. So the vertical angle theorem is very important. It is something that actually officially gets talked about later, but we kind of need to know about it now. So I'm just going to give it to you, even though we're not really talking about theorems. But something that's true about vertical angles every single time. Vertical angles come up a lot. So I just want you to think about this. If I have this x right here, and I just close the x, right, I'm squishing the top and the bottom angles, right? What do you think is true about the relationship between these two angles here? They're the same. So we say that angles that have the same measure are what? Congruent. Good. So what is true about vertical angles always is that vertical angles are congruent. Always, always, always. They come up a lot. We use them a lot. It's easy. They're congruent. Okay, it's the inside parts of the x. All right. Any questions? All right. So next we have complementary and supplementary angles. And boy, how does it make my head want to explode when y'all don't know the difference, because I know this is old news. Complementary angles. The first thing that you need to know about both of these is that they are pairs of angles. Okay, it's not 3, 4, 5, whatever. They are pairs of angles. So complementary angles are two angles, and supplementary angles, it's always two angles, right? So with complementary angles, their measures add up to give you what? 90. Complementary is 90, supplementary is 80, or 180. You are not allowed to ever miss that ever again. That is old business. It's easy. We ain't got time for mistakes like that. Okay? So complementary could look like this. Well, first of all, are these two angles complementary angles? These two. Yes? How do you know? Maybe. We don't know, right? What if I do this? Yeah. So they are complementary because they had to give me 90. Would both of these be 45? We don't know. Maybe, right? It's possible, but we don't know. Okay. So they could be adjacent, or they could be not adjacent. I think that's 60 and 30. So it doesn't matter if they're adjacent or not. That's irrelevant. Then I want you to think about if I said an angle measure equals x degrees, whatever it is. Then I want to know how algebraically to represent its complement. All right. So with 60 and 30, these two angles are complementary angles. So 30 is the complement of 60, 60 is the complement of 30, okay? So if the angle measure is x, what is its complement? How do I write that algebraically? So I just want to write its complement. So its complement equals something. So let's say I didn't give you this, and I gave you this, and I said, what's its complement? Yeah, specifically, what is it? What's the complement of 60? 30. If I didn't give it to you, how do you find it? Great. You're exactly right. I take 90 minus 60, right? That's easy. You know how to do that? Okay, so if the angle measures x, what's its complement? 90 minus x. Okay? Do you see how it's literally the exact same thing you do with numbers? That's why you have to take it back to something that makes sense to you. So if I ask you something like that, I'd be like, I don't know, that x makes my brain hurt, right? It's got to stop making your brain hurt. If I give you a number, what would you do with the number? You'd subtract it from 90 to get the other one, right? It's the exact same thing you do here. So this is just 90 minus x. But then we have to put parentheses around it so that the degree sign gets distributed to both. So does that make sense to you? All right. Then supplementary could look like this, right? Which means a linear pair is always supplementary angles. Or they don't have to be attached. One angle could be right here. The other one could be floating around in space somewhere. I can even draw it. So then if an angle measure equals x degrees, then its supplement would be what? Good. 180 minus x. Okay, everybody okay with all that? All right, so let's go back up to the top here. And I want you to draw this. So you have some room up at the top. Angles 1, 2, and 3. Are angles 1, 2, and 3 supplementary? No. Do they have to give me 180? Yeah, so, but they're not supplementary? Why not? Because there's 3 angles. These are angle pairs. So yes, 1, 2, and 3 add to give me 180, but they are not supplementary because it is 2 angles both times. So angles 1, oops, angle 2, and angle 3 are not supplementary. Okay. Any questions at this point? We good? Okay. All right. So let's look at this. It says find the measure of each of the following. The complement of angle M is what we're looking for. All right. So remember, you want to write everything algebraically. It's not just about being able to spit a number out of your head. So complement of angle M. So how do I write the complement of any angle? Okay, good. 90 minus x. So the complement is equal to 90 minus x, right? And x represents the angle measure that we know, right? So 26.8 is equal to x, basically. So that means that's equal to 90 minus 26.8. Okay, so let's do this in a logical fashion. What's 90 minus 20? 70. So we're at 70 now. Now what's 70 minus 6? 64. And then 64 minus 0.8? 63.2. You see how you do it in pieces? And you don't have to go borrow and carry and mess things up, or do it in your head without doing it in pieces and give me 64.2, which is the most common wrong answer. So here the complement that we're looking for is equal to 63.2 degrees. All right, so then we have the supplement of angle N. The supplement of any angle, how do we represent that? 180 minus x, which means this whole thing here represents x. So go ahead and set that up. That is, so far, no, not 100% right. If you're getting 200, you're wrong. If 200 is in your answer, you're wrong. So I'm just letting you know that. Maybe you can reevaluate. Right. What happened to your 2y? Disappeared, right? Do we have enough information here to solve for y? No, we don't. So when we plug this in, my supplement is equal to 180 minus 2y plus 20, right? So on the left-hand side, I don't have anything. There's not a 0. There's nothing because my answer is going to be an expression. So the supplement is equal to, what's 180? I get 180 minus 2y, and then what? Minus 20. So the supplement is 160 minus 2y degrees. Okay, can't mess up that minus the negative part. Okay, we good? All right, let's look at C. We're going to get through this example, and then that's, right quickly. We're going to finish this example, and then we're going to have to stop here, and then we'll start back up on Monday, which means I went ahead and gave you the homework, and I'll extend the due date. But you will, don't start putting up or anything yet, but you will just only do the word problems on the back. Don't try and do any of the rest of it because you're not ready for that yet. I don't want you going and making stuff up. All right, so let's look at this. It says an angle measures 3 degrees less than twice the measure of its complement. Find the measure of the angle and its complement. Okay? One of the reasons you hate word problems is because you don't know how to approach them. You read it and you're like, oh my God, I don't know what to write down. Well, me either. I only half paid attention when I read it the first time too. So we go back and we reread it and we translate from English to math. So when it says an angle measures 3 degrees less. So what do we represent an angle with? Look up at the top. An angle measure equals what? Look at x. It says an angle measure equals x, like twice. Okay, so an angle measure, right? So it's 3 degrees less than twice the measure of its complement. So this angle measure has to be 3 degrees less. Do I do 3 minus? No, it's minus 3. 3 degrees less means I'm subtracting 3. 3 less than twice. How do I represent its complement? No. How do I represent its complement? 90 minus x, right? So the complement is 90 minus x. So when you reread this, the angle measure is 3 degrees less than twice the measure of its complement, right? And do you see how you do it a piece at a time and go back and make sure it fits? Then you have it. X equals negative 3 plus 2 times 90 minus x. And then I just solve it. So x equals negative 3 plus 180 minus 2x, right? So I get 3x equals what? 177. Is 177 divisible by 3? Yeah, 7, and 1 is 15. So yes, so x equals, well, 3 goes into 17 5 times with 2 left over. 3 goes into 27 9 times. So x equals 59. So my two angles then are 59 degrees. And then you do 90 minus 59 to get the other one. Okay? So you should be able to do the complement supplements ones down at the bottom. Don't try and do anything else just yet. I'll give you, it won't be due Tuesday, it'll be due Wednesday, and we'll finish the notes on Monday. Okay? Have a great weekend, and